Question number 6. Which of the following gives dy dx if y equals log 2x minus 3? Okay, I know that this just means to find the derivative. And then it's asking me to find the derivative of a log. I know that the derivative of a log formula is du over u times ln a. Okay, so we just need to figure this out here. My du, this is going to be my u. My du is going to be 2, and then over u, which would be just be 2x minus 3, times ln of the base. A is the base. If it's just a log and there's no number there, we can assume that it's a 10. So that's what I would put. And then if I look at which choice would give that to me, it is A. So in this one, as long as you knew the formula, it was a real easy problem. Okay, question 7. If f of x is equal to secant theta cosecant theta, and g of x is equal to secant theta sine theta, then f of x minus g of x equals. Again, notice there's really no calculus involved in this one, but this might be helpful if we needed to simplify something after we had done the calculus. So that's why we're going to practice one like this. All right, it says to do f of x minus g of x. So f of x is secant theta cosecant theta minus g of x is secant theta sine theta. All right, I do notice that I can factor out a secant theta because they both have that. So I'll just write what I have left. And now I notice that my answer doesn't look anything like what I have. So I think I'll try, I'm going to keep secant theta outside, but I think I'll change cosecant. I know that it's equal to 1 over the sine of theta. Okay, and then from here I notice one is a fraction, one's not, so I think I'll get a common denominator, which would be just the sine of theta. And I'd have to multiply this one by sine of theta over sine theta. So I'll get minus sine squared theta over sine theta. So now if I simplify inside, I'm going to get 1 minus sine squared theta over sine theta. And then from here I'm still kind of stuck. I do know the Pythagorean identity, if you remember it, is cosine squared theta plus sine squared theta is equal to 1. That's called the Pythagorean identity. So if I solve this for cosine squared, notice I get 1 minus sine squared theta. So that's actually what it equals. So I'm going to go over here. That could be cosine squared theta. So I'm going to have secant theta times cosine squared theta over sine theta. And notice still that really didn't get me anywhere. So now I'm going to see if I can convert secant. Secant is equal to 1 over the cosine of theta. And then we have cosine squared theta over sine theta. And then I notice that we could cancel one of the cosine factors, so I'm going to be left with cosine theta over sine theta. And I notice still that doesn't match any of the answers, but I do know that cosine divided by sine is equal to cotangent. So I get to pick choice E. Okay, problem 8. Find the limit as x approaches pi of pi x minus pi squared over 2x minus 2 pi. Okay, on this one we're not going to compare the degrees because we're not approaching infinity. Instead, I'm going to try to plug pi into my equation. So if I plug pi in for the x, I'm going to get pi squared minus pi squared over 2 pi minus 2 pi, and that gives me 0 over 0. That doesn't mean that there's no limit, it just means I need to find a different way. So I'm going to try factoring on this one. I notice in the numerator I can factor out a pi, and if I do that I'll get x minus pi inside. And in the denominator I can factor out a 2, so I'll get x minus pi. And then I notice I can cancel the x minus pi's, so I'm just left with pi over 2. And as x approaches pi, there's really no place to plug the x. No matter what the x is, I will always get an answer of pi over 2. So B will be my choice. Okay, number 9, let f of x equal x minus 1 over x. Find f double prime. So basically we're just finding the second derivative. Okay, I'm going to rewrite this first. So I'm going to make this, instead of 1 over x, let's make it x to the negative 1. And now we just need to take the derivative 2 times. Okay, so my first derivative, the derivative of x is 1. And then in the second one, we'll bring the negative 1 out front to make it plus 1x to the, if I subtract 1 from the power, I'll get negative 2. So that was the first derivative. Now let's take the second derivative. The derivative of 1 is 0. And then the derivative of this one, bump my negative 2 out front. And then x, subtract 1 from my power, I get negative 3. And then if I just rewrite that, it'll be negative 2 over x cubed, which is choice D. And number 10. Okay, the function f is continuous on the closed interval -3 to 5, and it's differentiable on the open interval -3 to 5 if the derivative is greater than 0 over the interval, and if f of -3 equals -4 and f of 5 equals 12, then f of -1 cannot equal what? All right, we need to kind of tear apart this problem a little bit. Okay, if the derivative is bigger than 0, that means the derivative is positive. That means that our function will be increasing. Okay, so now I'm going to take those points that they gave me and graph them. I know that when x, this is your x value and this is your y, x and y, so the point -3, -4 is on your graph, and then 5, 12. Way up there. Okay, so we basically just need to see, and we know the function is increasing, so we don't know how it's going. I'm just going to draw it any way I want to. It doesn't matter. We know the function is increasing. That's the important thing. So we need to decide, when x equals -1, could the function equal -6? So could there be a point down there? No, there could not be a point down there because we'd have to decrease to get there, and we know our function is increasing. So A for sure is the right answer, but I just want to show you how the other choices, why they are fine. -1, -1 could definitely possibly be on my graph. -1, 4 could be on my graph because I would have to increase to get there. -1, 5 could be on my graph because, again, I could have to increase to get there. And -1, 10 actually could be on there because I could have drawn it. I could have drawn this really steep and then gone over like that. So definitely, in this case, your x could not. The answer could not be -6 because that would make the graph decrease.